1,000 starships. Talk about an ambitious plan. And yeah, I've been talking about it on this channel for over 2 years, especially in regards to what you could possibly use 1,000 starships for, aside from relocating a substantial portion of the Earth's population to Mars or some other planet. But really, where's the economic benefit in doing that? Yes, there's the idea of making the human species into a multi-planetary civilization, and that is an extremely important thing for the future of our species. But as far as short-term economic benefits are concerned, going to another planet really kinda comes up short. Going to the moon makes more economic sense, and that's something that I've talked about extensively on this channel. But something else that I've talked about a lot is asteroid mining, and unfortunately this is something that really hasn't been thoroughly embraced by Elon Musk or many of his contemporaries. It is an extremely high-risk prospect. It involves an enormous amount of investment, and really, how much benefit are you going to reap from a couple of asteroids that could be very difficult to get to and even harder to mine? Well, a little over 2 years ago, I released a video about this particular topic, or more specifically, about an upcoming mission that was supposed to be launched by a SpaceX Falcon Heavy. A lot of you have probably seen it in space news periodicals, the upcoming mission to the Psyche asteroid in the asteroid belt, a very unique asteroid, a K-class asteroid that is comprised mostly of metal, or at least that's what we think. A proto-planet, at least as far as our theories are concerned, that could be very similar to the core of our own planet. In other words, comprised almost entirely of metal, and more importantly, rare earths and rare metallic substances, which are incredibly important to today's technology and industry, and yet are very difficult for us to mine on Earth, very costly, and also very damaging to the environment. Mining a target like this could change everything for the future of our planet, but unfortunately, this mission is on the verge of being canceled, and I'm going to explain why in just a moment. But first, just a really quick word about how you can help my channel without spending a dime or looking at the description or anything else to support my upcoming journey to the Artemis 1 mission in Cape Canaveral. If you could activate the notification bells, as 15% of my subscribers have done up to this point, it would make a massive difference to the performance of my videos. Really, if 50% of my subscribers were to hit those notification bells, I wouldn't actually need to ask for any additional help whatsoever. The views on my channel would be enough to sustain me. Although I really do appreciate everything that everybody's done. You guys have been fantastic. Really, all that I require is for my subscribers to check out my videos once they come out, and it would make all the difference in the world to me. So if you can please click on that notification button. As I say, 15% of you have, and thank you very much for doing that. It will make a huge difference to me and cost you guys nothing. Let's move on. Now, the asteroid in question, as many of you have probably guessed by now, is 16 Psyche, and I've been talking about this destination for quite some time, but unfortunately, because of problems with software primarily, this probe is not going to be ready to go when it was supposed to go. Consequently, the mission is under review by NASA and subject to cancellation. Why is it going to be canceled, possibly? Well, because the delay is going to significantly impact the arrival date of the probe in the first place. We're talking about shifting it all the way to 2029 or 2030 as opposed to 2026 when the probe was originally supposed to arrive. This probe is loaded with a variety of different types of sensors to determine not only the magnetic field of this protoplanet, which is an important thing for us to understand how magnetic fields work throughout the solar system, but also its composition in detail. And as I've suggested in the past, the composition of 16 Psyche could be a tremendous game changer, not only for asteroid mining, but for the future of our civilization. This asteroid potentially has enough rare metals and rare earths important to our technology that could sustain our civilization for centuries to come. But there are other things that make mining this target incredibly attractive. For one thing, K-class asteroids, at least we think, have these metals and rare earths in extremely concentrated pockets, which makes it much easier to mine it, even if you're using mining robots of some kind, which could be very difficult to deploy on a target that has such a low gravitational pull. As we've discovered from the Bennu asteroid, for example, sometimes the surface of an asteroid can just give way beneath our probes. We don't think that's the case with 16 Psyche. We think that this is a solid hunk of metal and rare earths, which could be insanely valuable to the future of our civilization and also to any investor who is willing to put up the necessary cash to actually go exploit this stuff. This includes rhodium and platinum and gold and ruthenium and iridium, osmium, palladium, really a who's who of all of the most valuable minerals that you can find on our planet can be found on 16 Psyche. And it is this kind of treasure trove that could make a future asteroid miner, if he or she were willing to invest enough money in the enterprise, incredibly rich. For example, rhodium is worth nearly $500,000 US per kilogram. Not per ton, per kilogram. So think about how much 100 tons of the stuff would be worth. Now, granted, everybody's saying, oh yeah, well, if you dump that much rhodium on the market, then the value of rhodium is just going to go down and then you don't make any money. Well, the same thing can be said for any sort of major find in the future. Any major oil strike, for example, could theoretically drop the price of oil dramatically if you dumped all of it on the market at the same time, which of course you wouldn't, as OPEC has proven time and time again. As long as you have a stranglehold on the supply of this type of metal and release it in the amounts necessary to keep the price high and therefore to keep yourself rich, you could still make a killing on the stuff, assuming that you played the game intelligently, which obviously you would. But let's take the value down a little bit and say that it was 100 metric tons worth of gold or something like that. That's about $57,000 US per kilogram. You're still looking at $5.7 billion per starship full. That's a hell of a lot of money, especially when you consider how inexpensively Elon Musk is planning to operate Starship in the future. Even if you take his $2 million estimate per launch and change that to $100 million, that's still 5,700% profit. An insane amount of money that you could make off of this industry once you invest the necessary capital in an infrastructure to exploit the asteroids. And guess what? There have been many companies that have proposed a variety of different types of mining robots that could accomplish this, but what they have lacked is big-time funders. And generally what happens is they go bankrupt, or they don't have enough interest and they kind of wither on the vine, and it just doesn't work because there hasn't been anybody with the guts and the vision to invest the necessary capital in making all of it happen. And one unfortunate casualty of the general lack of confidence in the whole asteroid/lunar mining industry is Maston Corporation. They recently had to declare bankruptcy. Very, very unfortunate because they had some really intriguing and innovative mining robots, not only for the moon, but also for asteroids in the future. The whole principle of mining an asteroid amounts to this: assuming that you have a solid surface to anchor to, which a K-class asteroid we think probably will, then you simply anchor your robot to the asteroid and either drill down into the surface or burn down into the surface using high energy plasma, as is the case with this particular robot. Now, this is designed to extract water ice, but a similar principle could be employed by mining robots operating on 16 Psyche. Melt down a high concentration of rare metals or rare earths, extract the ore, and then launch them from the surface, and you wouldn't need a whole lot of energy, a whole lot of rocket fuel in order to get these minerals off the surface of an asteroid, simply because of the extremely low gravitational pull. As a matter of fact, the same high energy plasma you use to melt down the asteroid could theoretically be used to blast you off the surface of the asteroid to rendezvous with Starship with your cargo of rare metals in tow. Then you refuel at Starship. Keep in mind, Starship could carry a fair amount of fuel along with it to a potential asteroid mining mission. Go back down to the surface of the asteroid, melt down some more metals, extract some more ores, and return to the Starship. Rinse, repeat. And also keep in mind the logistics of extracting all of this ore might be a lot easier on one of these asteroids than trying to extract it from a mine here on Earth, simply because the rare metals are going to be in much more concentrated pockets and therefore easier to find, easier to melt down, easier to extract the ore than any potential target on Earth. But there are other enormous benefits to asteroid mining that go beyond the sheer profitability of this enterprise. Also, we're talking about saving the planet from destruction, because mining all of these rare minerals is incredibly destructive, especially considering that the vast majority of the mines are owned by the People's Republic of China, and these mines, mostly in Africa, are not very considerate to the well-being of the environment and oftentimes involve the use of child labor, as disgusting as that is. This is something that can be eliminated if we extract the very same minerals and rare metals from other sources throughout the solar system. Yes, it would take a tremendous amount of investment in the infrastructure to make all of this happen. We're talking billions of dollars, but that investment would turn into tremendous profit, and there are other benefits as well. For example, all of these new green energy initiatives such as wind farms, solar farms, that sort of thing, all of those require a substantial investment in metallic resources that have to be mined on our planet with a large amount of carbon invested in the mining, plus a great deal of destruction to whatever environment you happen to be mining it from. Whereas if you do it off the planet, the difference is absolutely colossal. And I'm going to give you a figure that will demonstrate just how moronic these people are who are arguing against expanding space industry because of the greenhouse gases that these rockets supposedly create. Mining a kilogram of platinum on Earth creates 40,000 kilograms of CO2 in the atmosphere. Mining a kilogram from an asteroid, and this includes the rocket greenhouse gas emissions, is only 150 kilograms worth of CO2. In other words, mining on Earth versus mining on asteroids is over 260 times more destructive to the environment. 260 times more destructive. If that isn't an argument for asteroid mining, I don't know what is. Forget the profits. If we're talking about damage to the environment, which everybody seems to be obsessed with these days, that is reason enough. Now put the profits on top of all of that, and you have all kinds of reasons for people like Elon Musk and Jeff Bezos to be investing heavily in this. And by the way, it appears that Jeff Bezos is the one who's focusing on this particular industry and not Elon Musk. Personally, I think it would be good to see Elon wake up to this, and who knows, he very well might, considering that a Falcon Heavy rocket is going to be carrying the 16 Psyche mission, or it may carry this mission assuming that it doesn't get canceled. And herein lies the problem. Because of gross errors with software installation and programming, many of the details we're still not entirely familiar with, we can't launch this probe on schedule, and that makes a big difference. As you may have noticed there, the probe is supposed to make a flyby of Mars in order to increase its velocity. This is no longer a possibility with the current launch window having been missed. As a result, the arrival time is going to get pushed out. On top of that, 16 Psyche and Earth are not going to be in the same kind of advantageous position to make the mission as short as possible, which means instead of arriving in 2026, 16 Psyche is more likely to arrive sometime around 2030, and that kind of a change in mission parameters can sometimes lead to cancellation. Now, perhaps an upgrade to the probe's ion thrusters or additional fuel for those thrusters or something along those lines might be able to make up for some of the lost time. However, that would be a very difficult thing to put into place from an engineering standpoint on such a short timeline, which means this mission may get canceled, and if it does, it's going to be very tragic, not only for the future of asteroid mining, but also for our understanding of the evolution of the solar system. If 16 Psyche is indeed a protoplanet of some type, it could give us an understanding as to why some planets form and some planets fail. It could also give us lots and lots of insights into the liquid metal core of our own planet and what it's likely to do in the future. That, from a scientific standpoint, is incredibly valuable on its own. This probe is supposed to spend 21 months in orbit, mapping Psyche in depth, utilizing a multispectral imager, which will also give us lots of insights into its composition, and also a gamma ray and neutron spectrometer, a magnetometer, and a radio instrument for its gravity measurement. The goal, among other things, is to determine whether or not this asteroid is indeed the core of a protoplanet or if it's something else. Plus, it will give us lots of insights into K-class asteroids. Are they indeed huge reservoirs of rare metals and other sorts of rare earths as we think they are, or are we completely off base? Obviously, this is information we absolutely need to know if any effort is to be made to exploit the resources of this asteroid in the future. We think it's a reservoir of these extremely valuable materials, but we really don't know for certain. And there is another factor to consider, at least as far as Elon Musk is concerned. Exploiting the resources of the asteroid belt is going to be far, far easier to do from Mars than it's going to be from Earth. And this isn't because of proximity, although that does make a difference. It's because of delta V and gravity. Like so many other things with our solar system, the more gravity you have to overcome, and therefore the more difficult it is to establish the infrastructure you need in order to engage in whatever enterprise you happen to be trying to set up, asteroid mining or otherwise, which means the reason to go to Mars, one of the most compelling reasons to set up a permanent human presence on the red planet, is to exploit the asteroid belt. It will be many times easier to do it from Mars than it will be from Earth, and perhaps that provides the long-term and short-term economic benefits to colonizing the red planet in the first place, not because Mars has huge amounts of resources that our planet and our civilization can make use of, but because the resources of the nearby asteroid belt can bring these kinds of benefits. Many things to consider, but none of them are going to make any difference unless this probe actually actually gets off the ground. So smash that like, hit that subscribe, please don't forget the notification bells, and as always, stay angry about space!